Okay, so we have this problem. It's an easy problem called kangaroo. So basically you have an x-axis and two kangaroos. The first one starts at x1 position. The second one starts at x2. And you have two other values, v1 and v2. They both represents the number of meters each, which is points on the x-axis, and it's always a real numbers. How many steps each kangaroo jumps. So v1 is for x1, v2 for x2. And let's look at an example they gave us. So this is x1, this is v1. So let me zoom just 1 second. This is, yeah, so this is x1, v1, x2, v2. So let's see. So this is where the first kangaroo starts. After the first jump, it will go to 3, then 6, then 9, then 12. The second kangaroo will start at 4 and move the first jump to 6, so 2 points, then 2. At the fourth jump, they will both reach the same point after the same number of jumps. So this is what the question asks. Does these two kangaroos reach the same point after the same number of jumps? That's it. So there's a few. The first thing, I think you noticed that we might need like a loop to always loop and calculate if we reach or not. We can solve it like this, but we need to make sure to test some cases before it. But what I noticed that we can't solve it for like an equation and solve it for y, for example. But if we read the constraints, x2 is always bigger than x1, so the second kangaroo is always ahead of the first kangaroo at the start, and the only way for kangaroo 1 to reach the second kangaroo at uh, to reach it at specific point after a specific number of jumps, or at least to go by it to pass it, that v1 should be bigger than v2. So this is the first thing we need to check it. I already typed it by mistake. So if v1 is less than v2, just return no. There's no way that since x2, since the kangaroo 2 is already ahead of x1 at the start, the only way for x1, the kangaroo 1, to reach it is to have a bigger jumping distance. So that's it. If v1 is less than v2, just return no. There is no way they can match. And the second case, I will solve it for y, solve the equation for y, and I will assume that they will match. So let me just open the console and try to explain it to you. Can you see it? Let me check the recording. Yes, you can. Let me zoom. Can I zoom? No, I can't. Okay. Okay, this is good. I can make it bigger. Okay, so x1 is the starting position of the first kangaroo, plus y, which is the number of jumps, times v1, which means this is number of jumps times the distance plus the starting position. It's simple, and should be equal x2 plus y, which is the same number of jumps, times the jumping distance v2. So let's try to solve it for y. First thing, I will move x1 to the right. Y times v1. I'm not that good at math, by the way. I think you can tell. So y times v2 minus x1. And now I will move the y times v2 to the left. So y times v1 equal minus y times v2 equal x2 minus x1. So until now it's very easy. Now I'm not sure what to call it in English, but I will do this move where you like get the common thing between them. So v1 minus v2 y times v1 minus v2 and equal to x2 minus x1, and now divide it. So y should be equal to, I don't need this, but to x2 minus x1. No, we need it. uh, on v1 minus v2. But what does so the number of jumps should be equal to this. So let's try to put it in a function and test it a little bit. So const y should be equal to a function, and implicit implicit, sorry. So this is x2 x1 v1, the same number, the same order of arguments of the function. So x1 v1 x2 v2. Sorry. And what I need to remove these. Okay, so we have y. This is the number of jumps. Let's test it to the examples that they provide. So 0 to 5, 3. So this is give us minus 5. But in this case, we'll get to this if condition and it will return no. So we won't care about it. But let's test it on the second example. I want to show you something. So 3, 4, 2. So this is 4. And let's try another example where this is 1, for example. I want to have a value with the fractions. I think 5. Yes. So what does this even tell us? So the first example where the v1 is less than v2, we won't even need to call this function, so this will just return no. But for this example, the result is 4, which means after 4 jumps, they will land at a specific point. And here, and this example, where x1 starts at 0, then moves 5 jumps each time, and v2 starts at 4, move 2 jumps each time. This means that they will reach at 1.3 jumps, which if you think about it, since they go only by integers, does not make sense. So if the number contains fractions, this means they will never catch up because it's not a real value that they can jump by it. I hope this makes sense. I think it does. That's how I understood it. 1.3 does not make sense because they only jump by integers, so they won't match at this point. So what we need to do is to say if, let me go to the function definition. So let me clear it. So this thing here. So if the thing will be if x2 minus x1 mod the v1 minus v2 equal to 0, then the result is yes, which means the function does not contain fractions. So let me just copy this, close this one. So this is the second thing I need to check for it. So else if equal to 0, return yes. Is it all capitals? Yes. And if neither of both get executed, I will just get evaluated true. I will just come here and return no. So by default, they won't match. That's it. Let's try to submit. I think that's it. And yes, it's correct. Okay, thank you.